Alright, let's look at the scenario where we are tossing a coin twice. So in the first toss we can get either heads or tails. Second toss we can get heads or tails as well. And this is the 4 outcomes that we can have when we toss the coin twice. And then let's make event A as having the second toss is a head. So we got tails and then head and then heads and then heads. And then let's make B as the first toss is a head. So we got heads and then tails and then heads and heads. And then if we look at the probability of A given B and then probability of A. So starting with probability of A. So that's just having the second toss is a head. So these 2 scenarios. So that's just 2 out of the 4 possible outcomes. So it's a half. Probability of A given B, which is probability of A intersection B over probability of B. The intersection is just the heads and the heads. So we go that's half. So that's, sorry, maybe I'll write it as 2 out of 4. So that's 2 out of the 4 outcomes divided by probability of B, which is also 2 out of 4. So this also comes out to be as half. So you can see the probability of A and probability of A given B is both the same. If we rearrange things a little bit more, and then we can get to this formula without, just having to remember the formula is not as good as understanding where it comes from. So what we're doing right now, we are dissecting this formula, and we know now that probability of A and probability A given B is the same. So I can replace this as probability of A. Then we can rearrange the equation so that it's probability of A B equals probability of A times probability of B. So this is how we get this equation, and this equation is a useful way for us to see if 2 events are independent of one another. So the word independent means it's not affected by the other. It results in on its own. So for this example, if we're tossing a coin twice, toss 1 and toss 2 are completely independent, meaning that if you get heads in toss 1, doesn't affect the outcome or the probability of your toss 2. So when 2 events are independent of one another, we'll have a scenario where probability of something or that thing given the other is the same, hence that we can use this formula to check if they are independent. So let's jump into this example here. So someone lives in a town, probability of them having more than one sibling is 0.6, and probability of they live in the east side of the town is 0.3. So where they live in the town and how many siblings they have, you would think that they have no correlation between the 2. So they are independent, in fact. So using this idea, we can find some probability of these scenarios here. So first scenario being a person from the east of the town having more than one sibling. So we're looking for probability of someone from the east having more than one sibling. So it needs to be part of the east and also having more than one sibling. So it needs to be east as well as having more than one sibling. Okay, because they are independent, this applies. So we know this is going to be probability of E times probability of S. And we know that's just 0.6, 0.3. It's given to us. It's 0.18. The next question, a person has no more than one sibling. So that's the opposite of S. So this is S complement. Right here. And does not live in the East. So that's the opposite of E as well. So what we're looking for a person, probability of someone that's not in S, intersection that's not in E. Now that's a bit harder to sort of think about, or at least for me. So I'll draw a quick Venn diagram. We know they're independent events, so E is going to have its own circle. So I should start with S, and then E is going to have its own circle. And then we know we're looking for S complement, so that's everywhere else but S. So that's going to be, we know S is 0.6, so that's going to be 0.4 times, maybe I should set it up with this. Because they're independent, we can again use this. So we know S complement is 0.4, and then we know E is 0.3, which means the outside has to be 0.1 because I have to add up to 1. So E complement is everywhere outside, so it's the 0.6 and the 0.1, 0.7, so 0.28 is what we're looking for here.